today's date, we are 3/24. Yes, it's Friday, but we're going to get through this, okay? Common Core Standard. What we're doing today is trig inverses, so we're finding angles from the unit circle in radians. It is an FIFT for functions and trigonometry. Okay. Now, what we want to do is find the angle. Okay, so it's just the opposite. We know that sine is a y value, so you want to find a y value on the unit circle. Y value in the unit circle that is 1/2. Okay, so it's found here and here. You always take the one closest to 0. So the angle is 30 degrees, but degrees for dummies, so it's got to be pi 6. See how it works? Okay, so the angle is pi 6. Okay. Sine inverse of negative 1/2. Okay, so it is here and here. Which one's closer?
The one over there. Actually, no, that one, because it's negative.
Nice. Have you done this before? That was good. Yeah. Okay, here's the trick. So we'll do it in terms of degrees to make the most sense. Okay, so if I want to get, I can either go all the way to here and travel 210 degrees. Or I can keep going all the way around and travel 330 degrees. That's a long journey, right? Or I can just, like Will said, just go down to it. But to go down to it, it's a negative 30 degrees, right? So it's going to be negative 30 degrees or negative pi 6. Okay for negative pi 6? Now, you can try to do your calculator, okay? Because your calculator is going to give you the right answer, negative pi 6. But if you do it in terms of degrees, right? If you do it, and if I do my mode, go back to degrees, right? Quit. If you did sine inverse of negative 0.5, you get negative 30 degrees, right? So it has to work. Because the answers we get need to be the same answers the calculator gets, right? But we want it in terms of radians, okay? Negative pi 6. Now, sine inverse of square root of 3 over 2. Okay, square root of 3 over 2 for sine value is right here or right here. Which one are you going to take? Pi thirds. It's that easy. It's that easy, okay? Pi thirds, okay? You can do this faster than you can do it on a calculator. The problem with the calculator is you won't get pi thirds. You're going to get an ugly decimal. You will. It's never going to give you pi thirds. Josh, who has do you have the fancy calculator? Who's got the fancy calculator? Okay. Yours might. James won't. Yours might give you it in terms of pi, but you'll have to read up on it and, so. Cosine. Okay, what do you think? Cosine is the x value, square root of 3 over 2 for cosine. Do you see it?
Yeah.
Lauren, which one is it? You're pointing right at it.
11 pi over 6.
Yes. Or pi 6. Which one's closer? Pi 6. Yes. Cosine inverse of 1. Find 1 for the x value. 0, right? You wouldn't want to say 2 pi because that'd be going all the way around the circle. That'd be kind of silly. So just 0, right? And that is an angle. Cosine square root of 2 over 2?
Pi 4.
Yeah, pi 4. You guys agree?
Yes.
Is this easy or what?
Yes.
Tangent inverse of 1. Remember the tangents are the red ones on the outside.
2 over 2.
Pi over 4. Tan inverse of negative 1. Or something closer. Well, you could go to here. You could go all the way around here, or you could take a short little journey down.
Negative side.
Negative pi force, right? See it? Negative pi force. And that's exactly what the calculator is going to give you is negative pi force.
Is it negative 7 pi force? Or do you not do what's...
Okay, so it's a rotation. It's an arc length, technically, okay? So if I'm going to go either to here, or I'm going to go to here, right? Or a short rotation is just to rotate down to it,
Okay.
right? Does that make sense? Now, why do we do these graphs? What was the point in the graphs, okay? Check out the graph, okay? Let me go back to my graph because I want to show you why it works. It's why we did the graph, okay? All right, so you ready? Let's have an aha moment. There's a tangent graph, right? Okay. Right there's your -1, right? That is, what's that angle there? Negative pi force, isn't it? So on this graph, it's right there, isn't it? Has to be. Because you'd have to jump to this graph or to this graph to get the other answer. But this is our main graph, right? That's why we looked at the graph, so we can put it together. Now, where are we at on this one? Tan inverse, square root of 3, where is it? Everybody agree pi thirds? Everybody see it? Pi thirds? Now secant. Doggone it, secant's not on the whole thing. But let me go ahead and show you how you do secant, okay? Now secant, what we're looking for is an angle, okay? So I'm going to set it equal to theta, okay? Watch, I'm going to go through this very slowly. But we're really looking for an angle, right? That's our whole thing, is our angle. Theta equals, theta equals, theta equals, theta equals. So we're looking for an angle. So what I want to do is rewrite this. So I'm really looking for an angle. But with secant, I don't have secant, but I have cosine, right? So I change this to cosine of some angle is equal to 1 over 2. Because secant is the same thing as 1 over cosine, so instead of 2 over 1, I put 1 over 2, right? So where do you find cosine of 1/2? Find it at pi thirds. Cotangent is the same thing as tangent inverse of 1 over the square root of 3, okay? Because you don't have a cotangent on the circle, but you have tangent, right? Now 1 over the square root of 3 is not really there, but when you rationalize this, right? When you rationalize it, the same thing as tangent inverse of the square root of 3 over 3. Now that you can find, can't you? Where's that one at? Pi 6 is the answer. Cosecant is not on the inner circle, but sine is. So if we change this to sine inverse, and we look at 3 over 2 square roots of 3, because I want 1 over that, right? I just flip the fraction, just like I flipped this fraction, just like I flipped this fraction. Now that's not really on there, but if I rationalize this, I'll have sine inverse of 3 square roots of 3 over 2 times 3. If I rationalize it, you know, if I multiply by the square root of 3 over the square root of 3, right? Remember how we did that, right? Square root of 3 over square root of 3, right? May as well cancel the 3's, wouldn't that be easy? So I'll have a sine inverse of the square root of 3 over 2. I think I can find that. Where's that one at? Where's that one at? Square root of 3 over 2.
That's pi 6.
Sine.
Pi 3.
Pi 3. Pi 3, you see it? For the y value? Pi thirds. So to do the cofunctions, we know the cofunctions are, this one's 1 over, secant's 1 over cosine, right? So I changed it to 1 over 2. Cotangent's 1 over tangent, so I made it 1 over that. Cosecant's 1 over sine, so I flipped it, 1 over that flips, okay? Alright, turn the page. Alright, here comes your world. You get to push buttons, huh? Here comes your world. So, back in the day, I remember this is kind of funny, because back in the day, kids were not all that good with calculus. You guys are fabulous with calculus, because you spent all day doing this, right? So you're really good with calculus. So, sine inverse. Now, we need to do it in radians mode. Because we don't do degrees, because degrees are for dummies, right? So this is easy, okay? So first I have to check my mode. Clear, check my mode. My mode's got to be in radian mode, right? Put it in radians. Okay, put it in radians. And then I'm just going to go sine inverse of 0.8, okay? And I get an answer. I get 0.927, okay? Now, before I go much further on this problem, because if you're just pushing buttons, you get an answer, What the heck does the answer mean? Well, check it out. I got a circle, right? I have an angle. I have an angle that's 0.9. No, that doesn't mean it's a little itty-bitty angle at all. It doesn't, because we know that right here is 3.14, right? That's an angle, right? So 0.94 might be right about there. There's my angle. Which we know that 1 radian is approximately equal to 57 degrees. Okay? You got that? This is an angle in terms of radians. It's about that big. It's a little bit smaller than 57 degrees. Okay? All right. Tan inverse of 5. Okay, just negative 5. Just do it. Okay, so clear. I'm going to go tan inverse of negative 5. And I'm going to answer about negative 1.37. Okay? So theta is a negative 1.37. Okay, what does that mean? Well, let me get my graph. Remember? Once again, let me grab my graph. Okay. All right. So if I take a look at my tangent graph, if I go to negative 5, if I just go negative 1, 2, 3, 4, 5, right, it's going to correspond to an angle right around there, okay? That would be your angle, okay? Which negative makes sense, doesn't it? Okay, then finally, cotangent. Well, there's no cotangent button on my cap. Josh, you may have a cotangent button. I don't. But what we can do instead is just do it as, oh, I'm ahead of myself. My bad. I was doing that one. Cosine of 1.2. What do you get? Error. 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 Why? Why? Okay, I agree. Why? Why?
It's not on there.
Yes, how come? I agree with you.
Is that the,
What?
is that the tangent?
No? No?
It's too big.
It is too big. Nice. Think about your unit circle, okay? You're looking for what's the biggest cosine? It's 1, right? To go to 1.3, you got to be out here. You're off the circle. It's too big, isn't it?
So how can tangent negative 5 work?
That's different because you're looking at. Let's look at the graph, okay? Okay, let's look at this. This is why we did the graph, okay? So look at cosine. Here's 1. Is there a cosine value up here at 1.3? No, there's no angle that corresponds to 1.3. It's too big, isn't it? But look at tangent. Tangent can be forever big and forever small, can't it? That's why we did the graph, so you guys can see how it's connected, all right? All right, so error. What about sine? Can you ever do a sine inverse of 1.2? Can you do sine inverse 1.2? Take the sine. Can you do that 1.2? No, you can't. You want to see something really weird? Check these out. Cosecant and secant can never have a fraction. All right? What about secant? Well, secant is not on our circle, but we could go and do cosine inverse of 1 over 3.2. I don't have a secant button on my calculator. Josh might. I don't. So I just change it to cosine inverse of 1 over 3.2. So I'm just going to go cosine inverse of 1 divided by 3.2. And I get an answer of about 1.25. Theta equals a 1.25. All right? I don't have a cosecant at all, but I can do it as a sine inverse of 1 over negative 0.5, right? And let's see how that works. So I go clear. I'm going to do sine inverse of 1 divided by negative 0.5. Domain error. Now, I didn't like that either. Well, if I take a look at my graph, my cosecant graph, all right? So my cosecant graph, okay? Here's cosecant. Here's negative 1/2. There's no graph there, is there? So it's also a domain error. Can't do it. Cotangent. Well, we don't have a cotangent button, but I do have tangent. So I can do a tangent inverse of 1 over 1.3. Let's see. I can't use my calculator. Clear that. Clear that. So tan inverse of 1 divided by 1.3, and I get an answer of about 0.655. Theta equals a 0.655. Okay? Not too hard. So, in today's homework, I want you to use the unit circle, all right? Here's why. When you get your test, your next quiz, which will probably be Friday, let me flip the page. I want these answers. If you give me a decimal answer, I will mark it wrong. But you'll argue they're the same. And it's easy to argue with pi that they're not the same, right? Because 3.14 is not pi. In fact, Nathan, as good as you are, you'll